Okay, class, we ended a little abruptly last time, but I want to get back on the placenta again. Here again is the placenta. So we want to concentrate this video on the placenta. We talked about the immunologic privilege of the placenta. We talked about this, okay, the chorion. I mentioned and showed you the different sides of the placenta, the fetal side, maternal side. We discussed the layers of the placenta already. Here's another picture of that you can review in my PowerPoints. We talked about amniocentesis. Okay. Now we're to, again, molecule exchange across the placenta. We said the maternal blood volume would increase significantly, and that was to have enough blood to adequately perfuse the placenta. Now, if you recall from my cardiovascular, if the maternal blood volume went up significantly, then hypertension could ensue. But one of the things that prevents that, one of the things that would prevent that would be a decrease in total peripheral resistance, systemic vascular resistance. Remember the MAP formula, mean arterial pressure equals to cardiac output times systemic vascular resistance. Well, with a bigger blood volume, cardiac output would go up, which would increase mean arterial pressure, but by a drop in systemic vascular resistance, also called total peripheral resistance, that would do that. But this drop in total peripheral resistance also would increase perfusion of the underside of the placenta from the mother's side. Now, two umbilical arteries, this is in the umbilical cord, two umbilical arteries deliver blood to the placental vessels, and the vein brings it back. So we have two umbilical arteries and the vein. So we're going to concentrate on that in just a second. All right. In this way, maternal and fetal blood do not mix. There should not be an exchange of maternal and fetal blood. However, at the time of delivery of the placenta and also along the pregnancy, there are microvascular breaks, particularly at the end. This is where we talked about in blood typing, ROGAM, and so forth. If the mother is Rh negative and the kid is Rh positive. But there's not intended to be any exchange of maternal and fetal blood. And we've discussed this earlier. What should happen, everything should occur by what? Diffusion across the tissues. Diffusion across this placenta. And so oxygen and nutrients diffuse from the maternal blood to the fetal blood, and then the fetus gives the waste and carbon dioxide there. All right, so let's go a little further. The placenta has a high metabolic rate in that it does a tremendous amount of protein synthesis. So it's not just sitting there to do the exchange. These protein enzymes are used to degrade maternal molecules and drugs taken by the mother that may harm the fetus. So medications, drugs, and various things produced by the mother, even normal metabolic products, biochemical products, try to be degraded by the placenta. That's part of its metabolic activity. The placenta also acts in hormone conversion. Now, some things can cross the placenta. Well, we already talked about Rh incompatibility, but other things, alcohol, lipid can cross, which can give fetal alcohol syndrome. And certain drugs like these here, cocaine, marijuana, and so forth, can also cross. All right, let's look here a little further. So here's the circulation in the placenta. Here's the maternal veins. Okay, so we're going to start here from the mother's side. There's a barrier. So everything should be by diffusion. The maternal artery would be coming from the mother. Maternal artery would be coming from the mother. It would be coming from the uterine artery aspect, and it would be bringing nutrients and oxygen, things of that. Then the maternal, then it would diffuse, and then here we begin the maternal veins that would come back up in here. And maternal veins would bring materials from the kid that diffused across to get rid of through the mother. Okay. Here is the umbilical cord. That's where it has the umbilical arteries. 2 arteries and a vein. 2 arteries and a vein. Now, remember, cardiovascular. Arteries are blood vessels that leave the heart by definition. Not all the time are they oxygenated like the ones we talked about in the lungs, the pulmonary artery. So the umbilical artery is bringing deoxygenated blood. And the umbilical vein is bringing oxygenated blood back because of the fact that it has been exchanged for the mother. Okay. Now I want to go to this picture next here. All right, here's basically a synopsis of the fetal circulation. So oxygenated blood is carried from the placenta to the fetus via the left umbilical vein, okay, which passes to the liver, okay, left umbilical vein. In the liver, most of the oxygenated blood passes through the ductus venosus. Remember, 2 arteries and a vein. In the liver, most of the oxygen passes through the ductus venosus. The ductus venosus is a bypass route through the liver. A bypass route through the liver. You don't want the liver to start breaking down things in the fetus because the mother's sending in good stuff. So the liver does not have to really get involved to reach the inferior vena cava. Now we've talked, you know what that is. The inferior vena cava enters into what? The right atrium. Okay. So then the foramen ovale, which we talked about in cardio, is open, and then blood will shunt from the right atrium to the left atrium through the foramen ovale. And then what will happen is from there it will go to the left ventricle, and from the left ventricle it'll go out through the aorta. But remember, you still have the ductus arteriosus. And so anyway, bottom line is that blood will come down, oxygenate all the tissues in the baby, come down here, and ultimately on these iliacs, this is aorta, on these iliacs will exit here, and these would be the umbilical arteries that would carry the blood. So here would be the umbilical arteries that would carry the blood, because they're blue because the blood is deoxygenated here. So again, just kind of study that fetal circulation there, and you'll see what I'm discussing. Okay. The placenta secretes protein hormones. Okay. Human chorionic gonadotrophin acts to stimulate the LH and ovaries thyroid stimulating hormone. Okay. Placental growth hormone. This is a growth hormone. Okay. Others, human chorionic somatotrophin. And others, human placental lactogen. So these are other hormones that are secreted by the placenta to aid with the developing offspring. So the placenta does more than just do the exchange. It does more than just do the exchange. The elevated blood glucose. Now, this human placental lactogen here, and human chorionic gonadotrophin, and human chorionic somatotrophin. Okay. So human chorionic somatotrophin work together, and I should have put here human placental lactogen, HPL. That's what I wanted there. Change it. HPL. These hormones here, change it, work together to increase lipolysis, to increase blood fatty acids, and glucose sparing. So in other words, bottom line, the mother's glucose level goes up. Why? To have extra glucose to provide nutrients to the kid. Now, what that would mean, though, is that all females, if nothing happens, would have gestational diabetes in pregnancy. But you're increasing the glucose level slightly, but not too much. If it's too much, then the lady has gestational diabetes, but you're increasing it enough in order for the fetus to have an adequate supply of glucose for energy production. Okay? So, the elevated blood glucose has a diabetogenic effect in the mother. The diabetogenic can result in polyuria, polydipsia, all of the various things that you would see with diabetes symptoms. The reason for the increased maternal blood glucose, as you can see, reason for the increased maternal glucose is to provide adequate glucose for the placenta's metabolic and the fetal metabolic activities. So to prevent most women from having gestated, the beta cells in the mother's pancreas proliferate to increase her insulin production so that she does not totally suffer gestational diabetes. Okay. Placental steroid hormones. See, these were protein hormones that we spoke of earlier. Let's go back. These were protein hormones. Human chorionic gonadotrophin. Okay, which stimulates LH in the ovary and thus placental growth hormone. All of these are protein hormones. Now we go into the steroid hormones. Okay, the steroid hormones would be the estrogen, placenta such amount of estrogen, progesterone. These are all necessary. These are all necessary, the sex steroid hormones presented by the placenta once it is formed. It's an incomplete endocrine gland and it requires the steroid precursor molecule cholesterol. So what am I speaking of? What I'm saying is it cannot make these steroid hormones. It has to have cholesterol. It cannot make cholesterol in the body is made from acetate, enzymatic actions to make cholesterol in the body. But it doesn't have the enzymes. But once the placenta has cholesterol, it can convert cholesterol into progesterone. Progesterone can be converted into androgen in the fetal cortex. Then androgen can be converted into estrogen. So the placenta itself cannot form androgen from progesterone. Thus, androgen must be obtained from the fetal adrenal cortex. Okay. Since estrogens form from androgens, then that's where everything comes in. So the fetal adrenal cortex must provide the androgens. Okay? Because all estriol comes from the placenta and not the mother, maternal test of the estriol, because the estriol is coming from the placenta, then estriol levels within the mother could be assayed, and if the levels are low, that may mean the pregnancy is in jeopardy, is what it says, and you can read through that. Okay, so let's just summarize this real quick. What will happen is cholesterol has to come from the maternal blood. Cholesterol can go into the placenta. The placenta cannot make cholesterol from acetate. Cholesterol can come in from progesterone. Some progesterone will go back to the mother, but some progesterone will go into the fetus, and progesterone can be converted to androgens, okay, because the hormone is there, the enzyme, is there to do that. Then androgen can diffuse back into the placenta, then androgens can form estrogen. Okay, so here's some of the hormones again. So now we're at labor and parturition, and I'm going to start a new video there.